Hello everyone, my name is Sahitya. I am from CSC department. Our project is comparative analysis of emotion classification using TF-IDFT vector. Coming to the abstraction, in current digital era, the emotion has become a important role in every social media platform. In order to improve the accuracy of the emotion for the user input, we have created the algorithm with TF-IDF algorithm along with the random forest model. Introduction. As we know that emotion has become a fundamental role in online communication. Our goal is to successfully recognize the emotion in the texts or phrases with the natural language processing. We have studied many literature reviews. From the top six which is related to our project are here. First one is semantic analysis using the learning approach over the emojis for the Turkish tweets. The main goal of this project is to predict the emojis for the Turkish tweets. This project was used the bag of words. The bag of words is nothing but converting the text or sentence into individual bag of words. The words are according to the frequency of occurrence of each word in the dataset. And coming to second one, handwritten emoji recognition using the convolution neural network. This project aims to identify the handwritten emoji using the convolution neural network. They have taken the 400 image with 8 types of emojis, and they have used the 4 filters in the CNN model like 16, 32, 64, 128 filters. And next one is emotion prediction from sentiment, from sentence. This project talks about the prediction of emojis from the sentence. The workflow of this project is firstly they have predicted the collected the data set, and next they preprocessed the data and feature extraction, and they find the emoji and target display the target emoji. They have used the linear SVM as it satisfies their criteria and gives them more accuracy among their model. And fourth one is early and late fusion of emojis and text to enhance the optimum mining. In this project, lately fusion has combined both texts and emojis as the input for understanding the sentimental analysis. In this approach, both texts and the emojis are taken from the emotions for the sentimental understanding. They have used several models like lexicon-based, machine learning, aspect sentimental analysis, so on like that. They have used this in this research paper. Coming to fifth one is pre-processing and emotion classification of WhatsApp chats for sentimental analysis. In this paper, pre-processing of data is firstly taken and the importance of emojis from the texts. In this paper, they have firstly done the pre-processing, like they collected the raw data, and pre-process is an important step in this project, and unstructured data into the structured data. They have successfully taken the various WhatsApp chats and separates the text and emojis and translating the sentence to the given language from this research paper. Sixth one is emoji and emoji icon in the tweet sentiment analysis. In this paper, emoji and emoji icon plays a key role. In this research paper, they have done in the Indonesian sentimental analysis, as most of the approaches are Western languages like English and French. They have done on the Indonesian language. These paper also used the SVM algorithm as it gives the more accuracy. Coming to the next problem identification. The problem identification of our project is inaccurate suggestion of the emoji based on the individual words instead of taking the entire sentence. The existing system may forecast the emojis based upon the individual sentence without accounting the total sentence meaning, which provides the irrelevant or inaccurate suggestion. Next one is our proposed methodology. First one, we took the data set. The data set contains of 3 columns and 40,000 rows. The 3 columns are tweet ID, sentiment, and content. Tweet ID is uniquely identified the number, and sentiment is emotion of the content, whereas content is the text which is identify the emotion of the text. Next, we have done this pie chart. This pie chart tells about the percentage of emotion in the sentiment column. As we can see, the worry column is more percentage, and whereas enthusiasm is with less percentage. In this pie chart, we can see the percentages of every column. Next. Data pre-processing. Data pre-processing is nothing but uncleaned data can be clean data set. By pre-processing it, we can get the most accuracy and minimize the noise. Firstly, we have data collected. Firstly, we have collected the data which is related to our project. Like it may contain texts, phrases, paragraphs with various types of emotions. And next, attribute removal. We have removed the attribute which is tweet ID, which is not required for our project, which is not useful for project. So we have removed the that attribute in order to get the best accuracy. Tokenization. Tokenization is a process of breaking the sentences or texts into small units, which is also known as tokens. It may, by using the tokenization, the system can easily identify the meaning of the content. Nextly, we have removed the stop words. Stop words like and or in our project, in our data set contains more number of frequency. We have removed the stop words so that it will minimize the noise and also it will give the best accuracy. By using of stop words, we cannot identify the emotion, so we have removed that. Nextly, we have encoded labels. We have encoded each emotion with a numeric value so that a system can easily identify the emotion and easily predict the emotion. Lowercase. Uh, in lowercase, we have converted all upper cases into the lowercase by this step. The system can easily identify and without confusion, it can easily identify the emotion of the text given by the user. Nextly, we have done remove punctuations. By removing the punctuations, it will minimize the noise and also gives the best accuracy. Coming to the data splitting in the next process of the step, after these pre-processing done, we have the data set is typically divided into two halves. One is training and testing in the ratio of 80:20. Next, these graphical representation of the picture which shows the mostly occurred words in the data set. As we can see here, the good and today, love, one, these all are bigger size. So the words are mostly frequently occurred in our data set as it's shown in there. Next, algorithm. Our approach or algorithm is first step of this algorithm is we have defined a set of emojis with the corresponding emotion labels, like happy emojis for happy sentence and sad emojis for sad sentence. Like that, we have defined 13 emojis with 13 emotions. Next one, we captured the user input by NLP, natural language process. Third step is identify the emoji in the text and match the emoji which is related to the user input. Fourth step is to map the emoji which is related to the user input. And finally, we have displayed the emoji for the emotion of the user. In this project, we have used the term frequency inverse document frequency method, which is well known approach for NLP processing and which is also tells the importance of the terms in the documents to identify the mostly occurred words in the dataset. It mostly used in document retrieval and text mining tasks, etc. Next, model contribution. After we have done the training and testing, we contributed six models and also calculated the accuracy. The models we have contributed are decision tree, random forest, KNN, Naviebase, SVM, and logistic regression. After contribution of model, we have also done testing. Like testing, in order to evaluate the model performance, we have done the testing using the user input, which is 80% is for testing and 20% is for training. As you can see the results, the bar graph shows the percentage of each model. As you can see, the random forest got highest accuracy and where Naviebase got lowest accuracy. The random forest is like 84% and the Naviebase with 39%. Rest of all, like decision tree is 84 and KNN is with 42, SVM is 68. Finally, I would like to conclude that by using our project, the user can easily identify the emoji in the recommended bar. Every time user need not to go to the emoji bar and search for the emotion which is required for the user input. By using our project, the emoji can be contained in the recommended system. So I would like to conclude that our project, by using the TF-IDFT algorithm with the random forest, it gives the most accuracy. It will save the user online users.
Now I will show the execution of the project. These are the different types of emotions in our project. If you type in the terminal python.app.py, it will execute. If you click the link, you can see the interface. As you can clearly see that I typed not fun, it will predict as sadness. Let's take another example. It shows worry. Thank you.